So in this video, I'm going to show an example where we solve a linear system using the LU factorization for a 3x3 system. Okay, so in lecture, we found the LU factorization for this matrix here. Okay, so here was the L, and here was U. All right, and so now we're going to consider a system of the form AX equals B for this A here. All right, so so consider solving a system of the form AX equals B. All right, and to solve this using the LU factorization, we're going to write A as the product L times U. So we have this equation. Okay. And what I'm going to do is I'm going to put parentheses around this part here, the U times X, okay? And I'm going to say let C, vector C equal U times X, okay? And actually, I want to reverse this here. I want to say let C equal U times X, all right? So we solve this system in 2 steps. Here's step 1. So step 1 involves solving. Now, if I let Ux equal C and replace it with C, we have the system LC equals B. And so we solve this system for C. Okay? Because what's unknown here is the C. The B is given, and now when we look at a specific example, B will be a given vector. C is the unknown, okay? All right, so once we solve the system for C, all right, how can we get our solution X? I mean, what we really want is X. Here's our system, AX equals B, X is unknown, okay? Knowing C, can we find X? Yeah, from here. Okay, so knowing C, we can solve X. So that's step 2. Solve Ux equals C for X. Okay. So now we'll look at a specific example using this 2-step process where B is a vector 2, 4, 0. So I'm going to say we're going to solve AX equals B, where B is the vector 2, 4, 0. Okay. So we have our LU factorization of A, okay, and so our first step is to solve LC equals B. So that so here's L. So that system looks like this. So there's L. And C is a vector with unknowns. I'll call them C1, C2, C3. And here's my vector B. And so I guess what I should have mentioned in our 2-step process was we're using a substitution process in both steps. Here, it's a forward substitution. Okay. I mean, both these steps are pretty easy because we get one of these unknowns right away, and knowing that unknown, we can get the rest. Okay, so this is, in step 1, it's a forward substitution. You'll see that in the second step, it's a backward substitution, or back substitution. So here you can see that this first equation leads to C1 equals 2. Okay, so C1 equals 2, and then the second equation says C1 plus C2 equals 4, so that if C1 is 2, then C2 must be 2. Okay, so I'll write out that equation. So the second row here says C1 plus C2 equals 4. Okay, and knowing that C1 is 2, we get that C2 must equal 2. Right? And then now our last equation is 3c1 minus a half of c2 plus c3, this equals 0. And of course, if c1 is 2 and c2 is 2, these two terms are 6 minus 1. So we have a 5 plus c3 equal to 0. c3 must equal minus 5. Okay. So we have our vector c. So c equals, and I'll write it up here, 2, 2, minus 5. Okay. And now we go on to step 2. And so let me erase this part here. And so the step 2 was to solve ux equals c. So u is here. So u is the upper triangular matrix. And our unknown vector x, I'm using subscripts. Our book likes to use x, y, z. Either way is fine. And now I put in c. 2, 2, minus 5. Okay? And so now this is a back substitution. Okay? So we can see that x3 is going to equal 1. All right, from our last row. The second equation is, let's see, 2x2 minus 2x3 equals 2. And of course, if x3 is 1, I plug that in. I get a minus 2 on the left. I add 2 to both sides. I get 4 on the right. I divide by 2. x2 looks like it's 2. And then now the first row here is x1 minus x2 plus 2x3 equals 2. And if x2 is 2 and x3 is 1, let's see, how does this stuff combine here? Well, a minus 2 plus 2, those will cancel. And so I'm left with x1 equals 2. So our solution x bar is equal to 2, 2, 1. So this is our solution using the LU factorization.